Hi, welcome to this video looking at surds, simplifying surds, expanding brackets with surds, and rationalizing surds. So rationalizing the denominators of surds. Okay, so this video is made for students that are bridging the gap between GCSE and A-level maths, okay, and it's appropriate for students that are going to be starting their A-level maths journey in September 2022 and even future years. So if you're watching this video in years to come, then it's still appropriate for students that will be starting A-level maths, whether it's this September or next September or the September after that, okay? As ever, guys, feel free to obviously pause the video, try and attempt all the questions first, and then press play when you're ready. This is the first question. Simplify the following. I've got root 3 times root 5. Now, the laws of surds say that if I'm multiplying with a square root, I can write it under one square root. So 3 times 5 is 15, so I can just write that as the square root of 15. Okay, so the first law of surds is root A times root B, where A and B are numbers, okay, or any real numbers, I should say, then it becomes the square root of AB, okay? So feel free to obviously make a note of that and copy it down if you need to, or it can also be the square root of BA, okay? It doesn't really matter which way around you write it, okay? But I can write it under one square root, okay? So root 3 times root 5 is the same as saying root 3 times 5, which is root 15, okay? Or the square root of 15. Okay, next one, guys. Root 7 all squared. Well, squaring something means multiplying by itself. So it's root 7 times root 7. Okay, using the first rule above me, I can write it under one square root. Okay, 7 sevens are 49. The square root of 49, okay, is equal to 7. Okay, so this one simplifies to a whole number. Okay, for that one. Next one, the square root of 49 over the square root of 7. Well, again, if it's the division, okay, and I've got surds, I can write it under one square root. Okay, so it becomes the square root of 49 over 7. Okay. 49 divided by 7 is just 7, guys. So I can write that as the square root of 7. Okay, so root 49 divided by root 7 is just root 7. Okay, for that one. Okay, so another law is the square root of A over the square root of B. I can write that as the square root of A over B. Okay, for that one. Okay, for that one. Okay, next question, guys. I've got root 12 plus 2 root 3. Now, root 12 is what I call a surd. Okay, so a surd is an unsimplified radical. So it just means that it gives us a decimal, okay, that is essentially like it is recurring. Okay, so yeah, it's non-terminating. Now, because 12 isn't a square number, that's why I class it as a surd, okay? Because the square root of 12 doesn't give us like a nice number for us to deal with. However, I can simplify root 12, so I'll do it over here, guys, because I've not got a lot of space, and then I may have to delete it afterwards for the future questions. So root 12 can be written as the square root of 4 times the square root of 3. And you may be wondering, okay, why have I used 4 and 3 for this example? Well, because 4 is the highest square number factor that goes into 12, okay, excluding 1, of course. Okay, so the square root of 4 is 2. 2 times root 3 becomes 2 root 3, okay? That one. Okay, so I can simplify root 12 to become 2 root 3. Now I've got 2 root 3 plus 2 root 3, which simplifies to 4 root 3, okay? Because I can only add surds if I have a common surd in between, okay? So I can't just do root 12 plus root 3 and get root 15. It doesn't actually work like that. I can only add and subtract surds with like the same base like surd component, okay? So root 12 is 2 root 3, so I have 2 root 3 plus 2 root 3. Think of it as like 2x plus 2x, I get 4x, but instead of the x, I've got a root 3, so it becomes 4 root 3. Just to be clear, guys, here, so please note that it's 4 root 3. It's not the fourth root of 3. It's 4 lots of root 3. Okay, the fourth root of 3 means 3 to the power of a quarter. Okay, but I'm multiplying here. Okay, so it's 4 lots of root 3. Okay, next question, expanding brackets with surds, 1 plus root 5 all squared, so it's a double bracket. I've got 1 plus root 5 times 1 plus root 5, okay, so it's expanding double brackets with surds, okay. And I do appreciate that I am going fairly swiftly through this, but at any point, if you're unsure, feel free to obviously pause it and re-watch back if you need to, and feel free to obviously comment, at the end of this video about any specific questions, okay? But we're looking at revising surds today, so this is all GCSE higher tier maths, okay? And it's appropriate for GCSE further maths students as well that are doing the further maths qualification, okay? But it's appropriate revision for those of you that are starting the higher that are starting A-level maths in September, okay? 1 times 1 is 1. 1 times root 5 is plus root 5. Root 5 times 1 is plus root 5. And then root 5 times root 5 is the square root of 25, which gives us 5, okay? So root 5 times root 5 is the square root of 25. 25 is a square number, so I can take the square root of that, okay? So again, another little rule there, that if I have root x times root x, then it will always give me x, okay? So root x times x. So any number times by itself under the square root symbol, okay, or the same square root symbol, will just give us x, okay? Collecting like terms, so simplifying this, 1 plus 5 is 6, root 5 plus root 5 becomes 2 root 5, so the answer becomes 6 plus 2 root 5, or 2 root 5 plus 6, okay, either way is fine, okay. And that's how we expand brackets with surds, okay? So make sure that you are happy with expanding brackets involving surds, okay? Single and double brackets, okay? Right, we are now looking at the next section, which is rationalizing the denominator, okay? And all this is to do with is making it so I don't have a surd on the denominator of my fraction. So this is my denominator, okay? And this is what I call my numerator, okay? Just obviously refresh your knowledge on that, okay? So 3 over root 5. Now I can get rid of this, okay, by multiplying top and bottom of this fraction by 1. Now 1 can be expressed in this particular case as root 5 over root 5, and it will become clear in a second, okay, of why I've multiplied by root 5, okay. Remember the goal here, so rationalize means getting rid of the surd on the denominator of my fraction. It doesn't matter if it ends up on the numerator, that's not an issue, but it's making it so I no longer have a square root, okay, symbol or number on the denominator of my fraction. Now 3 times root 5 is just 3 root 5. And root 5 times root 5, looking at the green one, root x times root x is just x. So root 5 times root 5 is root 25, which is going to be just 5. Okay. We now no longer have a surd on the denominator. Okay. So that's us finished with the answer. Okay. So rationalizing that, I get 3 root 5 over 5. Okay. Sorry guys about squashing my answer. Okay, I didn't really think it through about how much space I was going to need. Okay, but I'll do my best to obviously work with whatever I have. Okay, so that's the first one. Okay, so rationalize means getting rid of the surd that is on the denominator of my fraction. The next one, I've got root 2 over 3 root 3. Okay, so I don't want the root 3 on the bottom. Okay, so I'm going to multiply top and bottom by 1. Okay, multiply this fraction by 1, i.e. root 3 over root 3. Okay. Now, some of you may be thinking, well, why didn't I times by 3 root 3? Okay, I mean, I could have, okay, but then I would need to obviously cancel my fraction down. Here it doesn't really matter because when I multiply, and yeah, it will become clear in a second. Okay, that 3 at the front there doesn't actually change my answer. It just makes it 3 times bigger on the denominator, and that's it. Okay, so it doesn't actually change my answer. Okay, so root 2 times root 3, okay, becomes root 6. Okay, 2 times 3 is 6. 3 root 3 times root 3. Now, if I just ignore this for a second, okay, so I'm just ignoring that for a second. Root 3 times root 3 is root 9, which becomes 3, okay, and then reintroducing that 3 at the front, I get 3 times 3, okay, because that's from that 3 there, and root 3 times root 3 gives us this 3 here. 3 times 3, we should know, is 9. Okay, so the answer becomes root 6 over 9. Okay, for that one. So the answer becomes root 6 over 9. Okay, now some of you may be wondering, yeah, and obviously rightly so, thinking, okay, can I simplify the fraction? Now, where possible, we do want to simplify fractions. However, I can't simplify this because some of you may be thinking, well, I can just divide top and bottom by 3 and get root 2 over 3. That's not true because I can't actually do that, okay, in this, okay? So this can't be simplified any further because of this square root symbol here, okay? The only way that I could simplify it is I'd have to square it first and then simplify, okay? But like this, I can't simplify that anymore, okay? So don't be thinking that the answer simplifies to root 2 over 3. It doesn't, okay? That only works if I have nothing, okay, affecting the numbers on the top or bottom, whether it's a power, a square root, whatever it is that I'm dealing with, okay? Right guys, next question, okay, it's a slightly more trickier one. I've got 2 over 3 plus root 5, okay, so let's just do this in like a different colour. Okay, so this time I'm going to multiply, okay, by what I call its conjugate, okay, so I'm going to multiply top and bottom by 3 minus root 5 over 3 minus root 5, okay? So it's the same as this, but the sign has just changed here. That's all I've done. Now, the reason why I can't just multiply it by root 5 is because on the denominator, I would end up with a root 5 still somewhere, because I'll be timesing 3 by root 5, which would give me 3 root 5, and then I'd have root 5 times root 5, which is going to be root 25, which is just 5. So on the denominator, I'd end up with 3 root 5 plus 5. So that's why I can't multiply it by root 5, okay? And if you're not convinced by that, then feel free to obviously pause it now, multiply this by root 5 and see what you get, okay? But that doesn't actually cancel it, so I've got to multiply by what I call its conjugate, okay? So it's essentially the same set of numbers, okay, on the bottom, exact same, but this sign, it changes. If it's a minus there, it becomes a plus there. If it's a plus there, it becomes a minus there, okay? And this brings in the knowledge of the denominator becoming the difference of two squares, okay? So multiplying this, okay, 2 times 3 is 6, and 2 times negative root 5 is negative 2 root 5. Okay, on the bottom I have 3 times 3, which is 9. 3 times minus root 5 is minus 3 root 5. Root 5 times plus 3 is plus 3 root 5. And then root 5 times negative root 5 becomes minus root 25, which we should know that's going to equal to 5. Okay, so this now becomes minus 5. Okay, on here, guys. Okay, so tidying up the denominator now, okay, collecting like terms. 9 minus 5 is 4, so on the bottom I'm going to have 4. Minus 3 root 5 plus 3 root 5, they just end up cancelling. Okay, so it goes to 0. Okay, 0 root 5, which obviously, yeah, it just cancels. And then on the top I have 6 minus 2 root 5, okay, over 4. Now again, here I can actually simplify. I can divide everything through by 2, and I'll get 3 there. That goes. And then this becomes a 2. Okay, for that one. Okay, last one, guys. I've got root 3 all over 1 minus root 2. Okay, so I'll try my best here not to actually delete that so you can see that, but I'll try and obviously fit everything in here. So I'm going to multiply, okay, top and bottom by its conjugate. So I'm going to multiply it by 1 plus root 2 over 1 plus root 2, okay? And that's the idea that on the denominator, I get the difference of two squares, okay? If I just multiply the top and bottom by root 2, I would still have a surd, okay? I multiply by its conjugate, okay? Because on the denominator, I get the difference of two squares, which just leads to a number on the denominator, okay, and no surd. Root 3 times 1 is root 3, and then root 3 times root 2 becomes root 6. Okay, now I'm going to do this actually in one step, guys. I get 1 times 1 is 1, 1 times root 2 is plus root 2, minus root 2 when I times it by that, so minus root 2. Okay, that's going to cancel, and then I get minus root 2 times positive root 2, which goes to minus 2. Okay, so tidying this up, guys, 1 minus 2 goes to minus 1, so on the denominator it becomes minus 1, okay, and then dividing everything through by minus 1, it becomes minus root 3 minus root 6, okay, for that one. Or I can write it as minus brackets root 3 plus root 6, okay, if you're not very keen on putting the both minuses there. Okay. Okay. So, that's how I rationalize a surd, okay, or rationalize surds, okay. Right guys, so that's the end of today's video. So this is obviously part 2 of the bridging the gap between GCSE and A-level maths. So I sincerely hope you found it useful. I hope you found it informative. If you did, please hit that like button, please hit that subscribe button, and lastly, please click that bell icon. Okay, so hit that bell icon so you are notified of when I upload, okay, for GCSE maths, Key Stage 3 maths, Key Stage 2 maths, Key Stage 1 maths, and also A-level pure maths and A-level further pure maths. Okay, but that's it from me today, guys. Thank you so much for watching. Okay, take care, stay safe, stay healthy, and I'll see you in the next video. Okay, bye for now.